All right. Thank you very much, everyone, for joining another edition of our Liftoff webinar series. My name is Joe Steele. I'm the Senior Director of Communications and Legislative Affairs with Lyft. I want to thank everyone for taking time to join us today. Today, we are happy to welcome Techreo to talk about new innovations in forming metal pipes. I know that there are a lot of folks interested in our team to hear what Techreo has to say about forming metal pipes. So looking forward to today's presentation. A few housekeeping items. We are running this as a webinar. We are recording today's session, so it will be posted on our website at lift.technology later on today. So you can share it with folks who may not have been able to join it, or you can revisit and catch up on anything you may have missed previously. There is a Q&A function on the Zoom webinar platform, so please enter any questions you have there, and we'll be happy to facilitate the Q&A at the end of the presentation. In the meantime, if you do have your phones or computers open, please put them on mute so we can avoid any background noise as we go forward through the presentation today. So with that, I think we'll kick it off, but I do want to spend a couple of minutes sharing some information about Lyft for those who may or may not know about us and who we are and what we do. Lyft is one of 16 national manufacturing innovation institutes. We are sponsored by the Department of Defense along with 8 other of the 16 innovation institutes. And our goal is to drive American manufacturing into the future through technology and talent development. We believe we can do that through smarter manufacturing, which is the future of our economic security and resiliency. And we believe that the next region, next area that tackles smarter manufacturing will come out ahead. And we certainly want that to be the United States of America. So when we're talking about smarter manufacturing, what do we mean? We look at it like this equation you see on the screen now, the manufacturing equation that we work each and every day to solve. The connection between materials, processes, systems, and talent. So we're looking at manufacturing holistically, not just the materials, not just the process, not just the end system, and not just who's working on it, but all of those things put together are what we call smarter manufacturing. So we have team members each and every day working on materials, how they react to processes, and can those materials through that process end up in the system that we want to end up in. And all along the way, we're learning. All along the way, we are helping folks learn because we want to make sure that the advanced manufacturing talent pipeline is robust and healthy going forward to work on these new innovations in the future. So at Lyft, we have 2 programs that we operate. The first is our technology program, Leading Innovations for Tomorrow. And the second is Learning Innovations for Tomorrow. We try to marry the technology with the talent. And with that, you have Lyft in its entirety. So when we look at our Leading Innovations for tomorrow, this is a quick look at our 4 pillars of technology. As you can see, it's materials, processes, and systems woven in between all of those. From digital side, examining materials from the integrated computational materials engineering side, to agile and smarter manufacturing, to advanced alloy and process development and multi-material joining. And you can see on this screen here how deep we get into each and every one of those. I won't give you a quiz on that, but you can just see how widespread and deep our technology goes, both in-house and across our national ecosystem. On the talent side of the equation, Learning Innovations for Tomorrow, everything kind of wraps around and starts with our Ignite Mastering Manufacturing curriculum. That is a curriculum we developed through funding from the Department of Defense to really give a foundational understanding of advanced manufacturing to basically high school students, but can be used in community colleges to provide that, again, that foundational experience in advanced manufacturing, foundational understanding of material science, because we want to make sure that they move forward and look at advanced manufacturing as a possible career. That pre-COVID was held at our Lyft Learning Lab. Unfortunately, it's been closed for the better part of a year. But we, at any given time, we had 120, 150 students in our facility learning from us each and every day, taking part hands-on activities as well as virtual activities as well. So along with preparing students for the work that's going to take place in the future, we are preparing students for the jobs that are available now. So we have adult learners that are coming into our facility even during the time that we're in now, being very safe and being very cautious. But we provide skilled trades certification classes, welding and CNC at our facility, because we know those jobs are available now. We know that folks are in need of those jobs now, and manufacturers are in need of people to fill those jobs now. We also have a program called Operation Next, which is kind of tied into our skilled trades program that began as a program in reference to our support from the Department of Defense. We wanted to take a look at active duty soldiers, men and women in the military, before they get ready to leave the service. We wanted to provide them an opportunity to earn credentials in some of the most in-demand jobs available. So 6 months before they separated, we developed a program where they could earn credentials in CNC machining, industrial technology maintenance, welding, robotics. Very successful program. It is expanding across the country. Began as a pilot down in Kentucky. It is now available to the Michigan National Guard and their families. It is available to the Florida National Guard and their families. We're looking to make a few more announcements to other bases across the country this year still, to again, give our servicemen and women the opportunity to earn some credentials. So it's not thank you and good luck for your civilian career. It is thank you and let's help you start that civilian career. That program has also been expanded into the civilian world through the CARES Act that was passed by Congress last year. We are actually piloting Operation Next into industry, really to help small and medium-sized manufacturers get off the mat from the COVID pandemic. Here in Detroit and in Pittsburgh, we are training folks and providing certification opportunities in CNC, industrial technology, maintenance, welding, and robotics. And so we're very happy to get that in the civilian world. I mentioned that we are a public-private partnership between the Department of Defense, industry, and academia. We are a membership-based organization, nonprofit, based here in Detroit, Michigan. So what do you get out of becoming a member? Well, you get to work with folks like Techreo and reach into their capabilities and their knowledge base. But you also get everything you see on the screen here. We are a trusted advisor. We're not selling you anything, a specific solution. We want to help you in the best way we can move into the smarter manufacturing future. We are a technology accelerator, again, moving innovations from concept to commercialization. We work in the area of manufacturing readiness levels 4 to 7 to make sure that we can bring those innovations forward from research into commercialization. Technology showcase. We would love to have you in Detroit and host you to walk around our facility and show you the art of the possible. Unfortunately, we can't do that right now safely. We look forward to when we can, but in the meantime, please visit our website and you can walk through our virtual tour of our facility and we'll show you what we have going on there. We are a connector and a convener. That's why we're all here today. So thank you very much again for joining us. We want to bring together the brightest minds at the highest levels of government, industry, and academia together to make sure we are all working together to move the needle. We are a talent developer. As I mentioned earlier, through our Learning Innovations for Tomorrow, we're providing new venues, new techniques, and new tools to better educate the manufacturers of the future. And finally, we're a government partner. It can be overwhelming. It can be bureaucratic to work with the federal government, but we want to be that conduit to be able to take your innovations and get them into the hands of the warfighter as quickly as possible, into the hands of the marketplace as quickly as possible. We have seen some success from our early projects that have been commercialized and moved into the military very successfully. So we look forward to doing more of that with each and every one of you. So reach out to us directly via our website, lyft.technology, and we can certainly talk to you about becoming a member and all the other benefits therein. In the meantime, that is a quick snapshot of Lyft. I do want to hand the presentation over to Kevin and Charlie at the Techreo team to talk to us about their innovations in forming metal pipes. So I'm going to stop sharing my screen and ask Kevin to share his and tell you the show is yours.
All right. Thank you, Joe. Hi, everybody. I'm Kevin McNeil, president of Techreo. I'm going to cover the first part of the presentation. I'm going to turn over to Charlie Ritchie, who's also on the screen here. Charlie is our vice president of commercial development. So let's see. It's not advancing. There we go. Sorry about that. So Techreo is a technology startup company. We're in the Cincinnati area. And as Joe mentioned, we are focused on the development of high performance metal type pipes and tubes. So we'll start with a quick history lesson. So pipes were first used around 4000 BC. So they've been around a long time. Copper pipes were first introduced around 2500 BC. So again, a really, really long time ago. And the current versions of both welded and seamless pipe have been around in their current configuration for about 150 years. So a long time. These two versions account for about 99% of the metal pipe market. And while many refinements have been made, the fundamental pipe structure has really not changed much over those years. So we intend to be disruptive, and we've developed a totally new approach for how to make metal pipes. So the new manufacturing technology is very, very different in several key elements. And basically what we're doing is we're reapplying some key technologies from the paper industry, which is where several of us worked previously. So we start with coils of thin cold rolled metal. We then unwind the coil, feed it into the winder, and along the way we bond adjacent layers of the sheet metal to each other with welding and or structural adhesives. So there's some pretty general similarities to additive manufacturing in that we're building it one layer at a time. So this gives us the opportunity to differentiate by layer. That's pretty important. So we can change material at any point. We can change the thickness, the strength, topography, the bonding technique, pretty much anything we want by layer. A big difference from additive manufacturing, however, is build rate. So those of you who've worked with AM, you know it's pretty slow. Like maybe 1 to 2 pounds per hour of metal building. Our system is going to be much, much more productive than that. We think we'll probably be in the few thousand pounds per hour range. So that'll be a huge help for us in trying to minimize our manufacturing expenses. So again, a very versatile manufacturing technique that's also very new and different. So the new process has tremendous flexibility. So we can use any metal that you can buy in cold rolled coil form, which is really just about everything. There's very, very few metals that don't come in that form. So far, we've tested carbon steel, several versions of stainless steel, copper, aluminum, and recently an Inconel type alloy. So lots of flexibility in terms of materials. The bonding can be optimized for every application. So for example, we can use welding when we've got a application where we need high strength and a high pressure rating, or we can use structural adhesive, which is really good for building in insulation, noise, and vibration mitigation. So we can combine the two techniques and optimize the bonding for any particular application. A key capability is that we can also splice in and out of different metal coils, so we can use multiple metals in the same pipe. So today it's really, you just get one metal. There's a few minor versions out there like cladding, but we have tremendous flexibility here and can use multiple metals. And I'll show you some examples of that and what the benefit of that is. In fact, you can see in this one picture on the right, that's a prototype we made where it's copper on the inside surface of the pipe, which would be great for corrosion protection. Then we go to a relatively low cost carbon steel. And on the outside, we've got like a 316 stainless steel. So if it's going to be like in a saltwater environment, it's protected from corrosion from that. So even in a pretty simple, Schedule 40 type pipe, whereas the wall is about a 1/4 inch in that case, we've got 3 different metals. And it really was not a big deal to make that. We can also easily change the number of layers and the thickness of each layer. So again, we can use metals of different thicknesses. We can change that bonding gap between the layers. And again, it gives us a lot of flexibility for how we create the pipe structure. We can be very specific for the given application. And finally, we have the capability to integrate other materials or components into the pipe wall. So think things like insulation materials, temperature, pressure sensors, things like that. Even that becomes feasible with this technology. So the industry's got a lot of needs relative to metal pipes. And while the current options provide a pretty wide range of capabilities between welded and seamless, there's still a lot of issues and constraints. So think about corrosion resistance. There's a lot of good solutions out there like solid stainless, copper, Inconel, and they all work, but they don't really work great in that the higher end ones, they cost so much more from a material perspective that people end up not using them. So, how many times have you heard about a water main breaking? Well, if they'd used a stainless steel pipe, it never would have happened. But the, county engineer chose to use a low cost cement line carbon steel pipe, and 10 years later, the cement cracks, the water gets to the carbon steel, it rusts through and you got a problem, right? So there's good solutions out there, but they're not great because the high performance ones are so expensive because you've got to buy the whole pipe with full of that material, right? When you really only need it on the inside surface and or the outside surface. When it comes to weight, users generally accept whatever it is they get, right? Because there's not a lot of options. You can choose aluminum or titanium. There's not, I mean, if you're dealing with carbon steel and stainless steel, there's not a lot of options to get lighter and still work. So people sort of accept it for whatever it is. When it comes to insulation, I mean, there's many, many applications where folks need to insulate their pipes. And there's a lot of options out there. You've all seen fiberglass insulation, mineral wool, foams, aerogels, etc. And they all sort of work, but it's also probably the area that has the most frustration, because it's installed in the field. So you put up a pipe, you wrap fiberglass insulation around it, and then you fast forward a year or two, and what's happened? Moisture's got inside underneath the insulation. Now it's wet, it's nasty, it's not doing a very good job of insulation, and worse, there's nasty stuff growing in it now. Now you got to have somebody go up on a lift, tear it all off, replace it all, etc. So it's, insulation, there's options out there. But again, there's a lot of unmet needs where people are very frustrated with what they have to work with today. And then from a vibration damping standpoint, I don't know if anybody's ever hit a metal pipe with like a metal hammer, but they're kind of like a tuning fork. I mean, you get a loud noise and it rings and rings and rings. There's just no damping in it. It's a homogeneous metal structure, which is bad when you get into vibration issues. All you can do is put in a different type of pipe hanger that's got some foam or rubber, at the interface and trying to dampen that out. But it's really no way to kind of stop it at the source. They just sort of try and live with it. And then the last thing is faster, cheaper construction. I mean, I've talked to a number of construction engineers. They're pretty frustrated that, hey, it costs me more money to install the pipe than it costs to buy the stuff in the beginning, including expensive stuff like stainless steel. So, for example, if you're putting in like an 8-inch stainless steel pipe, you try and join two pieces together in a trench somewhere. One welder will take 8 to 10 hours to do one orbital weld to join the two pipes together. So all day long, you joined, piece number 1 to piece number 2. And that guy is about a $65 an hour welder. So there's a lot of frustration. There's, for as mature as the metal pipe market is, there's still a lot of unmet needs. So here's a few examples of our new pipe features available from the new manufacturing technology and how we can address some of those unmet needs in the metal pipe market. So I mentioned before, we can easily splice in and out with different coils and different metals. Here's 3 examples where we've done that. So if you look on the left, that's like the previous picture. So we started winding with copper. So that would be on the inside surface of the pipe. Then we transitioned to carbon steel, which is pretty strong, but also very cheap. And then we end up putting a stainless steel on the outside, so like a 304 or a 316. In the middle, we did the same thing where we went from, another example, we went from stainless to carbon and back to stainless. And over here on the far right is an example, a little higher end performance application where we started with Inconel and then went to carbon steel and then to stainless. Again, example like the last example, if you wanted a pipe made out of solid Inconel, they are super, super expensive. I mean, you can get them, but you're going to pay a lot of money. So with our system, we can put Inconel just where you need it on the inside and then transition to other metals that are cheaper. So if you think about it, with the current system, you're paying for all that expensive metal and it's in the middle of a pipe wall where it's really not doing you any good. We can tailor it by region in the pipe. Okay. Here's some examples where we can splice in and out and create lightweight options. So great for lift, which a lot of folks in this organization care about lightweight and strength to weight. So here's some examples where, on the bottom left, we started with a stainless steel. We transitioned out of that, went to aluminum for most of the pipe wall, then transitioned back to stainless steel at the end. On the bottom right is a picture where we started with a stainless steel winding, and this is actually a picture not of the finished pipe, but actually in the winding process. We paused and took some pictures. So you can see the stainless steel tube at the bottom that it's already been wound. And then you see the incoming sheet of carbon fiber. So again, this is an example where we didn't even use metal. We transitioned to a completely different material, carbon fiber, super strong, but also very, very lightweight. It's a great example of the flexibility and versatility of the technology. If it comes in sheet form, we can probably put it into a tubular structure. In these two examples, we saved, both of these pipes ended up being about half the weight of a normal pipe, if you just made it out of solid stainless steel. So tremendous weight savings are an option here. Here's a couple more examples where we did one with perforated metal. So this one was an example where about 50% of the aluminum has been removed. And you can buy perforated metal on the open market, so it's pretty easy to get. And then, and again, so a huge, you're already saving a lot of weight because you're using aluminum, and then half the aluminum's gone. So again, we would start with a solid stainless steel pipe, and you can see that on the bottom here where we wound, the inner part of the pipe in solid stainless steel. And we transitioned to this open aluminum material. And again, it's solid on the ends, so you're not going to have anything be able to migrate into the interior of the pipe wall. And then after we wind most of the pipe wall with that perforated metal, then we enclose that with a solid stainless steel on the outside. And over on the far right, this one's even a little bit more interesting, is that, you start thinking about Z direction deformation. So, in my previous world, working in the paper industry, we did a lot of things like embossing and fluting and so on. And here what we did is we wound the intersection of a pipe with flat stainless steel. Then we took aluminum and fluted it kind of by segments. So we went fluted, then flat, and fluted, then flat. So if you look at the adjacent layers, you can see we went from a flat section to a fluted or formed section, and then back to a flat one. So by alternating flute and flat, you can prevent the fluted ones from ever nesting together and maximize the offset they are, radially. So by doing that, you can get very good strength. Think about the cardboard boxes that Amazon ships around every day. If you look at the edge of those cardboard boxes, they all have some sort of fluted flat construction. So tremendous rigidity for not a lot of material. So this is basically reapplying that same technology into making a pipe wall, and we get the same benefit. Very, very strong with a lot less material in there and a lot less weight. I think these examples, we got up to about 70 to 85% weight reduction, which is really incredible. Think about how else would you ever get to that point with other existing techniques. You're just never going to get there. So the other, we talked earlier about insulation being a really big frustration. So here's a few examples of, on the bottom left, we wound a stainless steel pipe. We paused, and then we laid in some fiberglass insulation, and we wound another pipe around it. So yeah, tremendous rigidity. And again, it's open on the ends. In the real world, if we were joining these, they would be enclosed on the ends before we join them. So nothing would ever be able to get to that insulation. So you'd have a perfectly enclosed, hermetically sealed, insulation cavity. So the insulation would basically last forever with zero maintenance. The one in the bottom middle of the page, that's an example of aerogel. So it was totally enclosed. So I actually had to cut a hole in the pipe wall when we were done, so you could actually see the aerogel. So it was about a 3 millimeter or 1/8 inch thick mat of aerogel inside. So tremendous insulation capability. I think we had an R value of like 30 with this one. So, the ability to totally integrate any insulation material you want. And again, we can put in whatever material we want and make it as thick as we want. And then on the bottom right, we played with a fluted cardboard. So a really, really cheap version, but actually it had a pretty decent R value. And again, you've got to protect it from the elements, but again, we'd have it totally enclosed radially and both and on the ends as well. So another example of, tremendous flexibility here for totally integrating any insulation material you want. The other thing we talked about before was, trying to reduce vibration and noise. And we don't have a great view of this, but if you look at the bottom right, if you were to go through the radial pipe wall, you'd go from metal to adhesive to metal. And in an adhesive layer, we can do either solid adhesive or we can have adhesive with some air in there. So depending on the strength we need and how much insulation capability we want, we'll put in different amounts of adhesive in different patterns. But the key point here is that we've discovered that by building it in the structure, you get a tremendous amount of dampening that goes on between the layers of metal. So the metal layers actually don't even touch each other within the pipe wall. So A, great for insulation, and B, it's great for mitigating vibration. So I mentioned before, if you take a normal metal pipe and you hit it with a hammer, it sounds like a big bang and then like a tuning fork. If you hit our pipes, it sounds like you're hitting dead wood. So tremendous difference based on a totally different structure. And, think about huge reductions in vibration and noise are also possible with this technology. So again, lots of benefits come out of this totally new structure and new ways to make the pipe. So as you would imagine, we want to protect this, breakthrough technology. So we have filed a number of patent applications. We're protecting it both in the US as well as internationally. And we are, protecting the breadth of the new type products, that we can make in the different configurations, as well as how we do different connections from one section to another, as well as all the new manufacturing process techniques that we use to create the new pipes. So that's kind of an overview of the technology. And with that, I'll turn it over to Charlie, and he can take you through more of the business aspect of this.
Right, yeah. Kevin, can you keep sharing and step through, or?
Sure, I can do that. Okay. Yeah, takes a while to.
Okay, I'll just start. Just quick introduction and thank you. Hello, Charlie Ritchie here, VP of Commercial Development for Techreo. It's a real treat. I think we're still quite new to Lyft, but it appears to be a real energetic and supportive community / organization. So we're thrilled to be part of it. I almost don't have to read the bullets. The eyes just go to the 100B for billion. The global market is massive. Beyond huge, I think. So for steel pipe and tube, and then if we look at the stainless sub segment, where we think we have again a lot of with, as Kevin mentioned, the kind of inner layer of stainless and carbon stainless, sort of that sandwich approach. The stainless market is also massive at 35 billion. Our data was all pre-COVID, but the stainless market was growing annually 5%. In fact, today's news of what GDP at 6.5%, I think we're going to bounce back to that immediately. So we see that that market trajectory, market growth continuing, and this new technology offers breakthrough capabilities, as Kevin mentioned. It's a super mature market, and it's really ripe for some kind of disruption. So anyways, yeah. So we're excited about how our innovation can start to break through to do some more of those disruptions. So next slide, I guess, Kev. And I'll just I'll stall a little bit while Kevin goes to the next slide. But many, as Kevin mentioned, I think many parallels we see to the additive. I think if you go back, I don't know, 10, 15 years, kind of manufacturing or machining of CNC machining was pretty mature. A couple innovations around the edges, but pretty much very mature technology. But now with the additive, suddenly manufacturing, machining, part manufacturing is now kind of an explosion. And wherever we can remove constraints, and the designs are now blossoming, and all kinds of new things are possible. So we kind of see a lot of parallels to what we're introducing to additive metal, metal additive manufacturing 10 years ago, 15 years ago. So wide range of our potential applications. There's a wide range of corrosion resistant needs. I think everyone naturally switches to petrochemical. Good news is it's big. It does have these needs. Bad news is they're fairly for kind of the right reasons. Their risk aversion is kind of present in that market. But really, so many manufacturers. So there's always seems to be one process or sub-process which has corrosion resistant needs. So I think that's understanding where those needs are and addressing those needs is what we're after. As far as lightweighting, strength of weight applications, there are many. I know I work a little bit in the construction world. The more stuff you hang from the ceiling, the stronger the structure of the walls and pilings has to be, in magnifying the metal costs and construction costs. Also think about, I wonder how many miles of piping there is on an aircraft carrier. And everyone talks about, this, what do you call it, the old adage about how it takes a long time to turn an aircraft carrier. Well, lightweighting that would sure be helpful. So, in insulated pipes, we see a lot of needs everywhere, and it's been around the manufacturing world. That, as Kevin mentioned, that constant turnover of insulation is a constant, not a installation cost, but a constant going operational cost for so many companies. And we're looking at the very nature of the Techreo technology. Is this, we talked about basically like your double pane windows. This would be a 10 pane window as far as the layer, every layer providing a little bit of insulation via the small gap between those layers of metal. So the very nature of how we produce our pipes, without even trying to, we generate more insulation than a traditional homogeneous metal pipe. Vibration and noise damping, we've talked about that. And then I think particularly of interest, especially given kind of the new focus on green and lowering our energy footprint. This is significantly lower energy, both the production of the pipes as both the welded and seamless approaches. You have to turn the metal to very warm to orange. So that's a lot of energy in basically forming the two types of pipes today, the welded and seamless. Whereas our process is room temperature. So we know we're lower energy. I keep looking through websites and studies to try and quantify that. I haven't found anything reliable yet to kind of go and say publish, but we know we're in the right spot. We just need to kind of figure out quantify it. And then as far as use, that leans back up to bullets above to the insulated pipes. So where we think we're relevant to, I think basically anywhere that uses piping, and I think it might be easier to list those those industries that don't use piping, because there are pretty much everyone does. It's real ubiquitous. So Department of Defense, industrial, power, water, chemical, petrochem, food, oil, gas, aviation, etc. So I think the focus really there is etc. It's hard to get your grips around it because there are so many some good applications. So, and readiness. So we've been 2 years into this. We've done most of the key capabilities have been confirmed. We've done pilot scale testing and some lab work. We are successfully produced 70 prototypes, and then a wide range of diameters, and we've gotten up to down to 6 inches as well as long as 6 foot long. So we're growing in all of our dimensionals. We've now developed kind of rough plans for a demo line, and we're to confirm our manufacturing capabilities and do some initial production runs. So we're moving forward. We are, but still at that development and prototyping stage. Looking forward to the demo line. And I think the next slide is really the reason we're here, to not do so much talking, but also do a lot of listening. Really, this reach out to the Lyft community here on this call. And so any opportunity, based on what you've seen, what does this trigger? Is there, and I've actually checked the Q&A while Kevin was speaking. There are a couple of good ideas out there we'll chase down, but we'd love to have some kind of not sure how this works, Joe, as far as a discussion here, or do we do it via, email exchange later? But we're very much interested in opportunities you see, and also problems, like we are designing or knocking down the problems we know about, but as insulation and lightweighting and cost, and et cetera. But are there other problems you think that this could help solve? It's in other applications, and it would be of interest, of course. And then the next thing also is we're trying to break out of the kind of development and prototyping stage into more of a development partnership, moving into the our initial production line for the demo line. And then lastly, we're interested in really picking the brains of the participants here. Is are there any resources out there you could refer us to? We're looking for people with production knowledge, maybe sales knowledge, or consumers or purchasers of piping, users of piping. And we're looking for someone who could put us in the right direction of, again, all the above bullets, as well as other guidance. So we're both looking for organizations or people you think we should be in touch with. So I think that is the end of it. Maybe Joe, come back online and let us know if what's the best way to move forward with any of those any of those questions, or we'll maybe address the Q&A.
Yeah, that's great. Thank you. Thank you so much. Yeah. So both ways, right? We'll tackle the conversation here. But I encourage folks, if you want to go back a slide, Kevin, I encourage folks to reach out to the Techreo team directly if they have any questions to follow up. But you're right. There are some questions that came in, and certainly want to address some of those. If we can go through those with you right now and kind of carry on a conversation, I'll facilitate those. If folks, if you do have questions, please continue to add them to the Q&A. But the first one I'll ask is wow, who knew that there was so much innovation in pipe making, right? And this might fall in the category of why hasn't someone thought about this before? But where did this come from? Where did this, you're talking about your prototyping, getting your demo line up, and it kind of is an additive process that you, as you discussed. Where did this come from?
Actually, it's kind of an interesting story. Like a lot of innovations, it started off sort of unintentional, Joe. So when I retired from Procter & Gamble, I was working on a new technology for how to make steel engraved pattern rolls, which are used in the paper industry to emboss products. And I kind of failed at that, but along the way, I looked at what I came up with and I said, well, it's not going to work for engraved rolls because I can't figure out the topography, which has sometimes millions of individual elements on it. Said, but it's a pretty good base roll. I'm like, well, who would ever want that? And I looked at it and go, it looks a lot like a pipe. So kind of started down one path and never really figured that one out, but then discovered this other approach, which kind of opened the door to a myriad of applications in piping, which is, as Charlie said, is $100 billion market versus the pattern roll market I was aiming at before. I was like probably 1 million. So it was kind of like just exploring new technology in one area, and it didn't pan out, but I discovered some new ways to make cylindrical objects along the way, and it turned into this.
Yeah, you hear any number of innovations happening by happy accident, right? So
right.
So great to hear that story. And you're in the right place in terms of you mentioned getting to a prototype stage and getting that you're in the right place with Lyft, as I mentioned, in that MRL, TRL level 4 to 7. Hopefully we can work with you and make those connections. I know we have a number of our Lyft team on the call here today to hear, and I'm sure they will follow up with you afterwards. So you mentioned obviously pipes are everywhere, right? I'm looking around. I happen to be in my basement right now, and there's pipes everywhere. You mentioned aircraft carriers. You mentioned construction. What is the biggest market that you're eyeing? Is there a specific wheelhouse for this kind of technology, just based on material and cost, or is it just something that can be used everywhere?
I mean, that's a good question, Joe. We've talked to probably a few dozen people in the piping industry, and we've heard a lot of interest from a lot of different areas. I think the one that we'd probably were dissuaded from was the oil gas. I mean, the feedback from those folks, I think Charlie mentioned it before, is they're just pretty risk averse. After Deepwater Horizon and things like that, their perspective is it hasn't been used for 5 years somewhere else already. We're not touching it. So they've become very, very conservative in their choices of technology. So, but everywhere else, people are like, hey, as soon as you can make some stuff, I want to see it. Especially, I think it's the three biggest combinations are probably corrosion resistance, insulation, and lightweight. I mean, people often want some combination of those three. But again, petrochemical, just so many industries are doing things where they need corrosion protection and or good insulation and or they'd love to have it be lighter weight. So those three put together are probably the bulk of where we're aiming at. But again, there are just so many applications and so many industries that use those combinations. I'd hate to narrow it down.
It's interesting you brought up oil and gas as being one of the industries you're dissuaded from, and there's a couple of questions that actually came up about that. Given some of the environmental accidents that have happened, right? And we hear a lot of it in Michigan, surrounded by the Great Lakes. How do we transfer this the oil from Canada through the Straits of Mackinac, for example, and without risking the Great Lakes that we have here? It's interesting that you'd think that was one industry that might want the security of a new kind of pipe. So I don't want to push on the spot, but I will just say that there's a lot of folks, at least on this call, that think that this kind of application could be something that could prevent those kinds of accidents and catastrophes, if you will.
Yeah, I think you're right, Charlie. I mean, we poked pretty hard at oil gas early on, but again, we're still pretty early on in our startup, and we're not, we can't really make a lot to sell yet. So we haven't pushed real hard on the sales button yet. But I do think you're right. I think there's clearly opportunities there, and a lot of pipeline failures are again due to the fact that they had to pick a material that wasn't optimal, but they were forced into it for cost reasons. And if we bring along a solution, we're like, hey, we can give you exactly the corrosion resistance you want on the inside of the pipe, and you don't have to pay for that material through the rest of the pipe wall. People would start using the right material for the application more consistently, which is going to eliminate more pipe failures and environmental disasters and things like that. So, being able to put exactly what you want where you want it's got to be a big help for all of that.
Right.
Yeah. Especially those large pipelines. So it's I think a lot of people like if you look like the seamless pipe. If you ever seen the video, go online, YouTube, and see the video of that. It's the heat of this big round billet of steel. They heat it up till it's orange, stick a lance through it, and beat it open like it's dough. I mean, they widen and make it more, open up the circle inside of it. And it looks like, really? That's the 2,000-year-old approach Kevin mentioned, or at least 150 years, right? And in it's like, if you imagine, so we got to go from 24 to 36 inch. Like, oh, God, I'm not sure how we can do that. In our world, okay, we'll just use a 36-inch mandrel. We're just a bigger starting diameter, and it's not a big deal. And 37.5 inches we could do. You need it slightly thicker. That's 6 more wraps. It's the agility or the customizable nature of this is interesting too to me. So I think there's a lot of angles there.
Yeah, someone actually just asked, is there a range of diameters? Is there where you max out, or is there a minimum of how you can use this process?
We've probably considered the floor at maybe 1 to 2 inches. I mean, you get into things like brake line tubing and so on, and there's so little material to displace. You're not saving much. So I think where we can probably make the biggest impact is probably pipe that's a little bit bigger. So I'd call it probably 1.5 or 2 inch diameter and up. I'm not sure what the upper limit is. As Charlie says, there's not that much pipe that's bigger than say 36 inch. So probably I would bet our sweet spot's probably in that 2 to 12 inch diameter. That's probably, a huge percentage of the pipe market.
Sure.
But again, there's really no lower or upper limit. We could make probably anything.
And then folks want to know if the pipes are made via this process, how do they connect?
Actually, that's a good question. I did add a slide since the one I sent you, Joe, so I probably get a demerit from you, but I was in the lab this morning and took a picture. So that question has come up before. I thought, oh, I should get this picture. So what we do is right now, there's actually several options, but the one we prototyped so far is just a sleeve. So an advantage of this technology is that we can make the outer diameter really exactly what we want. So again, we just stop when we wind. So if you can measure the diameter of the pipe while you're winding, which is pretty straightforward, we just stop when we hit the target diameter. So here we made 2 pipes. We made them the exact same diameter. And then we made another pipe, which became the sleeve coupling. And the inside diameter of that was just slightly bigger than the outside diameter of the 2 other pipes. So we put our structural adhesive on, the outer part of the 2 pipes and then slid the coupling over it. And you end up with a coupling here. We also have talked about options where we can integrate flange couplings and things like that. We could also glue an end and then go to solid steel. So you could weld to like an existing pipe network and things like that. We've got to transition to the existing world at some point as we start putting pipes in. But this is an interesting one in that, current pipes, they don't really control the outside diameter very well. So you couldn't really do this. And everybody probably on the call is familiar, I bet, with PVC couplings, right? If you've ever done PVC pipe and you just kind of glop that glue in there and you do the cleaner than the glue and you just slide them together and it kind of sets up and you got locked up, PVC connection. We basically did the same thing here. So if you're putting these 2 pipes together in a field, you basically get some structural adhesive, glom it around both ends of the pipe, slide it together, to slide the sleeve over it, and you're done. So pretty simple.
Excellent. There's a comment here actually regarding your process and the patents you're exploring, that they believe that there was a few decades ago a steel tube that was available commercially that was created by heating a spiral wound copper plated sheet steel to form what became a brazed tube. I don't know if you're aware of that, or that might be,
Yeah. It's a good question. There are pipes sold on the market today that are called spiral welded pipes. So they do bring a sheet in and they do wind it. And I'm glad you asked that, because that's one of the key things that differentiates us from a lot of that prior art. Is a lot of that was, again, spiral, where the incoming sheet comes in at an angle relative to the longitudinal axis that you're winding around. So we used to do that like in core making and things like that in the paper industry. It's pretty common. And they still do that for very large diameter, like drain pipes and things like that. Like I've seen videos, they'll make a 96-inch diameter pipe by bringing in, say, a 2-foot wide strip, and it kind of goes around a helical axis. And then they have to weld, one side of the strip to the other side that's already been wound, and you create it that way. So there's a lot of art out there that has to do with spiral winding, but we're different than that. We're what we call convolute winding, where the incoming sheet is exactly perpendicular to the winding axis, so that that's a key element in that we can wind however many layers we want. If you go to the spiral world, or helicals, it's sometimes called, now you have to have a different infeed system for every layer that ends up in that tube. So if you want a 10-layer pipe, you've got to have 10 unwinding coils. You'd have 10 glue application systems, 10 web handling systems. I mean, it's much, much more complex. So if you're ever going to do like, hey, I need 50 miles of pipe that's 2 layers, helical and spiral might be a good option. But for a lot of things where we're trying to differentiate within the layers of the pipe, you really need to do many layers, and then you're into the convolute world, which is where we're at. And that's where it's, I think a lot more unique relative to the prior art.
So kind of in that vein, someone asked a question about how thin of a material can you use in this? Can you like foils, for example? But I want to follow up on that because you heard me mention, and this about Lyft, that we work a lot of, we're trying to figure out materials and processes, right? And make that connection, explore different materials. Do you work with your customers on which materials, or do you envision working with your customers on which materials make the most sense for which application, and kind of walk them through that process to say, hey, this will work better than that, or that you should try this approach? So
yeah, absolutely, Joe. It's a good point. I mean, I think And that's a key advantage of this technology is that we can dial in lots of capabilities for the application. So, I mean, today people oftentimes buy a Schedule 40 pipe because, well, Schedule 10 is not good enough, and there's no option for anything between Schedule 10 and Schedule 40. And they really needed sort of the equivalent of like a Schedule 18, but nobody sells Schedule 18. So they put in 40, and it's way heavy and it has way higher pressure rating than you need, and you're spending more money, and it's just they're overdoing it. So what we anticipate doing is talking to folks about the application, saying, okay, how much pressure rating do you really need? How much, deflection strength do you need? What do you need for insulation? What do you want for light weighting? And then we can figure out all these variables we have, how to optimize that for the given application. And you really can't do that today. You just got to pick from an assortment of a few things you can buy, and then you got to try and, field fit things on top of that after you buy it and install it. So we'll be able to do a lot of that on the upfront and be able to design it, so it's optimized for your particular application.
And someone did actually ask about high pressure systems. So that is something that's doable. You just need to take a look at it and design it for that specific pressure system.
Right. I mean, so we actually did some, we sent a bunch of prototypes to an external lab here in Cincinnati, independent lab, and had them test the strength of the pipe wall. And the good news is so we tested a pretty wide range of, low strength metals to high strength metals, thin wall, thick wall. And there's an equation called Barlow's formula that you can use to calculate the tensile strength of a pipe wall, and that correlates exactly to the pressure rating of that pipe. Mm-hmm. And the good news is we tested, I think, 15 different pipes, and they all came out plus or minus 10% of what the formula said, which is kind of incredible. I mean, you're doing testing to failure, you usually don't get that good of a correlation. So bottom line is we can pick the materials and then make the pipe wall whatever thickness you want to hit whatever pressure rating you need. So on a higher pressure application, we would use higher strength, metal. We would probably weld versus structural adhesive, and we would wind, thicker walls.
Excellent. I know
part of the quick tangent back to Kevin. You're made up, but the Schedule 18 example is one thing this can do, and I'm not sure where. I know this problem is rife in like military, like B-52 with aging parts. We don't have spare part manufacturing for some parts where you were made specific, and now the factory that made those parts is now gone, for example. So one thing we can do is, and I'm not sure if this is how applicable this can be, but small lot. If you need maybe back in the day, someone made 4.5-inch pipes for the XYZ system, and there's no more made. Well, we can make a 4.5-inch pipe, and we can make it custom, by properties as well as dimensionally. So, normally you have 4-inch pipe and you get a mile of it, but we can make 25 feet of 4.25 inch. So that's the one thing I'd like to throw out there. If anyone knows of any needs of small lot / custom, that's a feature too.
Well, I think you're in the right place, because at Lyft we are very active in the DMSMS category for the military, the diminishing manufacturing sources and material shortages, right? So these some of these things you mentioned, B-52s, tanks, whatever happens, some component somewhere, right, was made to last, made 40, 50 years ago. That manufacturer is now gone. They need a couple of them. We certainly are involved in that process, and glad to have you on board for that really.
Yeah, so we're help there too.
Exciting. Yeah. And someone did ask, talking about just engagement, and we can go on for days with this, because I know our team is very interested in helping you get involved with the Department of Defense and NASA and all the other folks I mentioned. We are a government partner and want to help our members and folks get involved with those organizations, and you certainly seem ripe for that. But someone asked if you are active in any industry associations, like NACE or the National Association of Corrosion Engineers, things like that, just to help you kind of get engaged with those groups and potential customers.
Yeah, we are. It's a good question. We are, part of ASME. There's the tube and pipe and Fab Tech are the typical pipe things. You got API. Charlie and I talk frequently. It's been hard with COVID because they canceled so many things, but we're also getting engaged now that I think a lot of conferences are hoping to be back in person this fall. So
Mhm.
example, FabTech in Chicago, I think they're hoping they're going to actually kick off September 13th. There's a Tech Connect conference in DC. I think it's
Yeah.
in October or November.
October.
We're signed up for that as well. So we're trying to, you know, reach out into all these you know, trade organizations that can get us connected to the different companies and different organizations that could tap into this technology and find the right home for it. So we're, you know, it's like I say, it hurt. COVID definitely hurt us because a lot of that face-to-face went away and those conferences went away. But the good news is it looks like, you know, folks are betting that they're going to be resuming around September in person.
Yeah.
So we're signing up for all those, and we're going to, you know, be getting the word out and doing the best we can to leverage those organizations.
Well, good. I do want to be cognizant of everyone's time. I know we're reaching the top of the hour. So if you do have questions to follow up, please reach out to these guys directly to ask them. We'll supply them with all the questions that we're asked just so they can follow with you as well. I know our team will likely follow up with you just to make sure that we are connected with you in the right way. So thank you very much for the presentation today. This is awesome. We really appreciate we appreciate you as a member, and we appreciate you giving the presentation today. So thank you very much. I do want to remind folks to follow us at Lyft via our website or our social channels. Stay tuned for other webinars. We do have one coming up next Thursday with Lifeline Fire Hose, talking about an innovation they have with saving lives of first responders by delivering air through the same hose that they're fighting the fire with. So that'll be exciting. So stay tuned for that. But in the meantime, I want to thank Kevin and Charlie and for presenting today, and thank everyone for joining.
All right. Thank you, Joe.
Our pleasure. Yeah. Thanks, Joe.
everybody.
Thank you very much, everybody. Enjoy the rest of your day.